Okay, now we're going to go down to simplifying. So we're adding complex numbers. So if we go to 19, so let's go down here to 19. And notice down here we're adding and subtracting complex numbers. Okay, so if I'm adding in between, okay, it boils down to just like when they were algebraic terms. If I'm adding, I can just drop off parentheses, so it's 9 minus 6i plus 8 plus 9i. So I do 9 plus 8, those are like terms, so it's 17. And then negative 6i plus 9i, which is plus 3i. Okay, so we have a non-I part and an I part. That's a complex number. Let's look at number 24. So 24, now I'm subtracting. So if you distribute this negative sign, on the first part we can just kind of drop off parentheses, so it's negative 10 minus I. And then we distribute the negative 1 here, so it's going to be plus 9 minus I. So now I'm going to combine my negative 10 plus 9, which is negative 1. I'm going to combine my negative I and negative I together, which is negative 2I. So it's negative 1 minus 2I. If I go down to 33, well, now I am multiplying. Okay, so the next one I'm going to do is 33 right here. Okay, I have 7i. Now that's like a monomial times a binomial, so I have to distribute. So it's going to be 14i, 7i times 2, plus 7i times 3i is 21i squared. Now we have to remember that I squared, by definition, is negative 1. So this is negative 1. So this really becomes 14i plus negative 21 or minus 21. And we could leave it that way. Typically, the best way to write them is with the non-I part first. I know this is kind of opposite of what we do algebraically, but negative 21 plus 14i, then it'll kind of be in that a plus bi format. You don't have to do that. Either one of these is okay. Let's go down to 40. Notice I have a binomial squared, and if you think about what we did algebraically, even with radical binomials, when you have something squared, you've got to write it out multiplied by itself. You cannot just square each term. So I'm going to do 3 plus 3i times itself, because that's what squaring means. 3 times 3 is 9. 3 times 3i is plus 9i. 3i times 3 is plus 9i. And then 3i times 3i would be 9i squared. Now, I squared is negative 1, so this last term really becomes 9 times negative 1 or negative 9. So I have 9 plus 9i plus 9i minus 9. 9 minus 9 on this one actually drop out. They equal 0, so I don't end up with a real part here. 9i plus 9i ends up being 18i.